I'm sure many of you watching along at home are not new to the world of GraphQL. But what if I told you that your GraphQL APIs could be supercharged thanks to some recent advances in technologies? Would that be interesting? If you answered yes, you're going to love this talk. If you answered no, you're going to love this talk because you're about to learn something completely new, which is why you're here after all. Taking to the stage next up for the 2021 CityJS conference is Jan from Amsterdam in the Netherlands. Jan is here today from Lumigo, where he is a developer advocate. In this session, Jan is going to be looking at the AppSync technology, which promises to make building your GraphQL APIs a breeze and, more importantly, super performant compared to their vanilla counterparts. That sounds amazing, doesn't it? If you have any questions about AppSync or GraphQL or anything connected to this talk, please do join us for the Q&A session immediately after this one finishes, where we will be putting your questions to Jan himself. Don't forget, post along on social media using the hashtag CityJS2021. We have really enjoyed reading all of your comments as they've been coming in today. Thank you very much if you've been posting along, and don't forget, keep your comments rolling in wherever you are watching at home. Jan, it is my honor to hand the stage over to you.
Hi, welcome to this talk on the AppSync and why your next serverless project should be using AppSync. So my name is Yan Cui. I'm one of the AWS serverless heroes, and I'm also a developer advocate at Lumigo, as well as an independent consultant that works with clients all around the world and help them adopt serverless successfully. So recently I gave a talk around how I helped a client of mine build a new social network in just a few weeks using serverless and AppSync. And it's one of the things that really made me fall in love with the AppSync and how productive it can be. And also it inspired me to build a new video course that teaches other people on how to make the most of AppSync and Lambda and DynamoDB as well. So in this talk, I want to start by just going back to the basics and talk about what is GraphQL and how it differs from REST. So GraphQL basically contains two parts. As the name suggests, it's a query language for your APIs that lets you subscribe, or rather describe, what data you have and what you can do with the data. But it also needs a runtime that can take a query written in this query language and then fulfill the query with the data you have. So every GraphQL API has a schema that defines what query and the mutation operations it supports. Queries are for reading data and the mutations are for updating them. So a client will send a query or mutation to a GraphQL server, who will then validate the request against the schema and process the request. There are GraphQL server implementations for just about any language you want, but for this particular talk, we're going to focus on AppSync, which is a managed AWS service that fulfills the role of a GraphQL server. So the schema is the contract between the client and the server, and it's not just a piece of documentation that's generated from the server-side implementation like many Swagger or OpenAPI specs. A GraphQL schema, it doesn't just document the operations a GraphQL API supports, it defines them and is binding. So when the client sends a request to the GraphQL server, the server will validate the request against the schema. So the client can't ask for data that don't exist in the schema, and the arguments that is sent has to be the right type, and so on. And then the GraphQL server is going to map each of these request type or field to a particular resolver who is responsible for fulfilling the request. And those resolvers can fetch data from different data sources such as DynamoDB, Rds, or Elasticsearch. And whereas with REST APIs, you make HTTP requests to a URL like this, where the path follows some hierarchical structure that leads you to the data you're looking for, and typically returns the data in JSON. In this example, I want the user's profile for user ID 1234, and the API takes the user ID from the path as my argument. And with GraphQL, there is only one entry point for all your requests, and the convention is to use the HTTP post and pass the request argument as the body. Another important difference is that as part of my request, I have to specify what fields from the profile do I actually want in the response. And since I only ask for the first name and last name, those are the only fields that are going to be returned in the response. Now, the same works for nested fields and arrays as well. If I imagine, there's a friends array on my profile, and I can say for each of the friends, what fields do I want in the response? Let's walk through a real-world example. Perhaps it's going to help you crystallize things in your mind. Imagine you're building a social network app and for people to do sports together, and as part of the app, you have a profile screen where you have to show your name, your location, a profile image, and some background image as well. And the list of the sports that you do and how good you think you are at each sport. As you can see, I'm not very good at any of them. And then you also need to show a list of the activities that you've organized yourself and that can then that other people can join, like a basketball match or jogging in the park. And for each of these activities, you want to show when and where it's happening and how many people are going to take part and so on. With the REST API, you probably start by getting this user's profile, right? But notice that the user endpoint returns a lot more information that we don't actually need to display in the UI. And this problem is known as overfetching, where we have to fetch data that we don't actually need, which wastes valuable bandwidth and the CPU cycles on both the client and the server. And worse yet, it also doesn't return all the data we need for the UI. So we end up having to make even more requests to other endpoints to get the details of each sport, as well as to get the list of activities for this particular user. And that all adds additional round trip between the client and the server, and it's not always possible for you to do this in parallel, which is going to add delay to how quickly we can render the UI, and that's going to hurt the user experience. And this is known as the underfetching problem, or the N+1 requests problem, which is another source of inefficiency and waste in many applications. And to combat some of these problems, a common pattern that emerged was called BFFs, or backend for frontends, where the frontend team would create dedicated APIs for just the UI page they're working on, and this backend for frontends, or BFFs, would act as proxies to other APIs to reduce the number of round trips between the client and the server, and to give the front-end team more control over what data are returned, and to mitigate some of the impact of overfetching and underfetching. But you do end up creating a lot of BFFs, which is a maintenance overhead, and you also end up doing a lot of duplicated work, potentially duplicating logic between different BFFs, as well as duplicating logic between the BFF and the backend APIs. For example, many of your pages need to fetch information about the user, and so the same fetch logic need to be implemented and defined in lots of different BFFs. And with GraphQL, there's essentially no need for you to write bespoke BFFs for every time you need to work on a new UI page, since the client has a lot more expressive power to ask for whatever data they need and only get the data they want. So to implement the same UI using GraphQL, I can ask for all the data I want and I need for this page in a single GraphQL request, where as an authenticated user, I ask for my profile and I specify that in the response, I want my ID, first name, last name, gender, and so on. And the GraphQL server will fetch this from a profiles table in DynamoDB. And for each of the sports, I need the display name field as well as the image URL. But wait, the list of sports in the profile only contains the ID for the sport, because we don't want to be because we want to be able to change the display name and image URL for the sports. So we don't want to bake them into every user's profile. So we're going to need to get the display name and the image URL from the sports table, and kind of like a join in the relational databases where we join by these two fields. And then we select the display name and image and the image URL. GraphQL kind of handles that for us and maps those fields for individual sports to a different resolver and fetch them from the sports table in DynamoDB. So we're good there. There's no need for the client to send two separate requests, saving us some additional round trips, which would have been necessary if we were doing this with REST. And for my activities, since I can have many activities, these are actually stored in a separate table altogether away from my profile. But each activity has a different user ID, so I can find my activities by looking up my user ID. And we can associate this activities field on the profile type to another resolver, which will then fetch the activities from this activities table. And we can also further expand any of the nested objects in the request, for example, for the first name and the profile image of the other users who has asked to join my basketball match next week, which would then be coming from the profile table as well. And as you can see, this is all very flexible. The client can basically ask for any information they need in a single query, and it solves the problem of overfetching and underfetching, and the client can ask for just the data it needs, nothing more, nothing less. And the GraphQL schema itself is also a strongly typed contract between the client and the server, which also doubles as both request and response validation, because the client can't ask for data that is not exposed in the schema, nor can the server return any data that's not been defined in the schema either, making it much harder for attackers to try to steal information from your system. And it also solves one of the main pain points of using NoSQL databases like DynamoDB, where there are no joins, and you typically have to perform joins in your application code. Here, GraphQL and AppSync kind of takes care of that for you as well. And with all things considered, GraphQL makes it much easier for you to build data-driven applications and enable front-end teams to really quickly iterate on the product and the user experience, and has become my default choice for building new applications. And I hope by the end of this particular talk, you feel the same way as well, especially given how easy it is to build scalable and performant GraphQL APIs with AppSync, which is a fully managed GraphQL service that lets you build scalable GraphQL APIs without running any servers. AppSync basically performs the job of the GraphQL server and is responsible for processing requests and mapping different parts of the request to different resolvers, which are then responsible for fetching data from different data sources. So out of the box, AppSync supports 5 data sources right now. Firstly, you can have AppSync resolver send HTTP requests to any HTTP endpoints, and it's a great way for you to put GraphQL in front of your existing REST APIs, so you can keep existing pages where they are talking to their own BFFs, as in backends for frontends, or maybe those pages would then go straight to the backend REST APIs. But when you start to work on a new page, you can use the new AppSync API instead, and over time you can gradually migrate those existing pages to use the AppSync API instead. And in time, you can also deprecate those existing BFFs, so everything will go through the AppSync API. At that point, you might also decide to simplify how you organize your backend APIs. If most of them are just doing basic CRUD operations against some DynamoDB tables, you might also decide that, well, the REST API layer isn't adding a lot of value. It'll be easier to just go straight from AppSync to the DynamoDB tables, especially if they're all owned by the same team and have to change in tandem with the AppSync API schema. And the DynamoDB is also one of the other supported data sources. And then there's also RDS, or Relational Database Services, from AWS. It's also worth noting that the AppSync integration right now only works with the data APIs for Aurora serverless databases in RDS, so not all RDS database types are supported. If you need to have the full text search, then AppSync can also integrate with Elasticsearch. That is the Amazon hosted the Elasticsearch service. You can map GraphQL operations straight to an Elasticsearch query, which is very useful if you need to build search features in your application. For anything else, you can always have a Lambda function where you can write custom logic and connect your AppSync API to any other service you want as well, be it other AWS services or other SaaS services such as Algolia, which I think is much nicer to use compared to Elasticsearch. You even need to build some kind of a search feature in your application. So AppSync itself is also very scalable. The GraphQL subscription implementation can support millions of connected clients, and your AppSync API is also deployed to multiple availability zones out of the box, which gives you a really great baseline for resilience as well. And you only pay for what you use at the $4 per million query or mutation operations. So even if AppSync has to run multiple resolvers for a single query operation, that still counts as one operation as far as your cost is concerned. Whereas with REST APIs and API Gateway, because of the underfetching problem, the equivalent request might translate to several HTTP requests to API Gateway, which would easily end up being more expensive, even though on paper, API Gateway is cheaper than AppSync per million requests. And with GraphQL, every request goes through the same entry point, so you can't just cache everything by the URL. So no caching at the CloudFront level for that matter. Luckily for AppSync, it has built-in caching support, which charges you extra based on the size of the cache node you choose. Essentially, you're going to be paying for uptime for a memcached node. But the good news is that the cache node itself is fully managed, and you can either cache the entire request or you can cache the result for a specific resolver. AppSync gives you a lot of room for mix and matching here, and a good caching strategy can make a world of difference for performance, scalability, as well as for cost. When you're running at even a moderate level of scale, this is going to be quite important, and it can help you save a lot of your cost by cutting out most of the requests that's going to your DynamoDB tables or Lambda functions or whatever backend databases you're using. So AppSync also has got built-in monitoring and logging support through CloudWatch metrics and the CloudWatch logs, and you can get high-level metrics like the number of API requests, error count, and latency, which is great, but unfortunately, all of these are aggregated at the API level, so you can't tell how well each resolver is performing, and where there's an error, which operation and which resolver is actually the problem. So to get more information about what's happening on the request, you can enable logging, and at least for the dev environments, you can set the field resolver log level to all, so you can get information about what's going on inside a resolver and how well each resolver is performing. So this way you can narrow down the problem to specific requests and the resolvers. But given how much logs the API AppSync is going to write to CloudWatch logs, this can also be a problem in production, which is why it's usually disabled in production by default. So what you can do instead is you can write some custom code to enable and disable this full logging in production, which is what I tend to do in my projects. And for debugging performance issues, you can also enable X-ray as well, which put a bit of light on what's going on under the hood and shows you where the time is taken on the request. And you can see that this single query has resulted in quite a few DynamoDB calls behind the scene. And you can see how long each of those requests is taking, and also which of these requests are made in parallel or sequentially. And X-ray also shows you a service map, so you can get a high-level view of which services your AppSync API is talking to and their overall health. The problem with X-ray is really that it's quite hard to find traces for specific GraphQL operations. So I don't find it to be particularly useful, then at least not as useful as it should be. And that's where tools like Lumigo comes in, which can really make your life much easier when you're working with AppSync and give you the ability to find transactions by the top level GraphQL operations that the client is making. So finally, AppSync gives me all of these capabilities, and I don't have to run any servers at all, so I can get a lot more done than I would do otherwise if I have to spend a lot of my time just looking after the infrastructure. But how does AppSync compare to API Gateway then, which I'm sure many of you are much more familiar with? I mean, we've seen some inherent advantages that GraphQL has over REST, but there are also a few things that AppSync does really well compared to API Gateway on top of all the benefits that you get with just using GraphQL. So we talked about caching, monitoring, and AppSync supports Websockets through GraphQL subscriptions as well, and also integrates with AWS WAF or Web Application Firewall, which lets you configure firewall rules for your API and has many built-in rules that you can just enable. that can block suspicious IP addresses or requests that are missing some headers for authentication. And you can also just configure IP-based rate limiting rule as well, which can block some naive denial of service attacks. It's got direct integrations against a number of AWS services as well as HTTP resolver. You can actually or you can use a Lambda resolver if you need to write custom code or execute more complex business logic. In terms of authentication, it supports Cognito, AWS IAM, API keys, and OpenID Connect for working with any OIDC compliant services. And the API Gateway, on the other hand, has got caching, monitoring, WebSockets, and direct integration with support with WAF as well. And it also has got direct integration with most AWS services. However, this often requires writing quite a bit of custom VTL code, which is not everyone's cup of tea, and it's also difficult to test as well. In most cases, you probably end up using Lambda proxy and implement the REST endpoint using Lambda functions. In terms of authentication, API Gateway supports all the different options that AppSync does, and there's some more. It supports a Lambda authorizer, so you can use it to implement custom authentication logic, and its API keys also support the rate limiting and the quotas as well through usage plans, which is very useful for SaaS applications where you often need to limit how many API requests an API client can make per month. So it supports custom domain names as well, which AppSync doesn't support right now, and you can create the private endpoints that are only accessible through your own VPC, which is something that AppSync is also missing. And you can also support resource policies, which, amongst other things, lets you implement allow or deny lists by IP, which is useful for business-to-business applications where more modern authentication options may not be available. And you can also lock down access to your API by known IP addresses as well, such as your private VPN. So in terms of the overall feature set, API Gateway has got a few more things in its locker, with quite a few useful features that AppSync doesn't have quite just yet. But there's a couple of things that AppSync does much better compared to API Gateway. For example, if you need to implement the group-based authentication where you need to model different access levels, for example, admins can do everything, but other users have only read-only access. With Cognito, you can create groups and put users in those groups, and you can also associate each group with an IAM role and the precedence value for selecting which group is applied for permissions if a user is in the multiple groups. However, when you use a Cognito authorizer with API Gateway, this whole IAM role and the precedence thing is just not applied automatically. So API Gateway only checks if the user belongs to the group, to the user pool. If it doesn't, then the request is rejected. It doesn't actually perform any checks against which groups or use the IAM roles associated with the groups in any way. So to implement group-based authentication, you have to do it yourself by first assigning IAM roles to each group to control which endpoint a user can access, and then make sure that you set the precedence value on the groups as well, so you can pick the most appropriate group if a user belongs to multiple groups. And then you have to write the Lambda authorizer. And that's right, to implement group-based authentication, you can't actually use Cognito as authorizer. You have to write custom authentication logic, and you need a Lambda authorizer for that. And the Lambda authorizer needs to validate the authentication token with Cognito and make sure the user actually belongs to the belongs to the user pool, and then set the user details so that get the user's details so you know which group the user belongs to. And then based on the precedence on those groups, you pick a group for this user and then generate the IAM policy based on the IAM role that's associated with that group. And if this sounds complicated, it's because it's hard work. In AppSync, group-based authentication with Cognito is built in. You just say in the GraphQL schema what groups can perform this action, and that's it. Done. It's pretty much effortless, and it's pretty self-explanatory as well. And then the requirement that often pops up is request and the response validation. API Gateway does support request validation. You need to specify the request schema for an endpoint. And if a request fails validation, then you don't pay for it, which is great. It's a good way for you to protect yourself against some naive attacks. But there's no response validation. Even though you can specify a response model, but that model is only used for the purpose of generating API documentations. So to implement response validation, you have to do it in your own code, perhaps using something like MIDI, which is a middleware engine for Node.js applications, which is a language-specific solution, and there might not be an equivalent of MIDI in other languages. And response validation is often overlooked, but it's actually quite an important tool for preventing data leaks. For example, if we were just to read an object from DynamoDB and return everything, maybe there are data points that shouldn't be returned, like date of birth or address or credit card numbers. Or if an attacker has executed some kind of a SQL injection attack against us and tricked the API into returning everything we have in the database. And the security is as much about what your application should do as what it shouldn't do. And it's entirely possible to do a good job of request and response validation with API Gateway. But once again, it's hard work and something that you have to do, and it's easy to forget. And the good news for GraphQL and AppSync is that request and response validation is built into how GraphQL works. The client can't ask for data that's not on the schema, nor can server return any data that's not on the schema neither. And if there are data that should only be returned when I view my own profile, but not when other people see my profile, then I can simply define two separate types in my GraphQL schema, one for my profile, my private profile, and the one for my public profile, and make sure that any search and other operations that always return a public profile. And therefore, it would entirely eliminate the risk of accidentally returning a user's private information to anybody else. And let's also talk about WebSockets. Both AppSync and API Gateway support WebSockets, but the developer experience are quite different. API Gateway has had the WebSocket support since 2018, and the way it works is that when someone connects to your WebSocket API, you can use a Lambda function to handle the onConnect event. And if you want to use that connection later, say to send messages to that user, then you have to record the connection ID somewhere, maybe in a DynamoDB table. And if you're building, say, a chat application where you want to send push notification to everyone in the group, whenever someone else in the group sends a message, then you need to map the connection IDs against this group ID. And equally, whenever a user disconnects from the socket, you have to have the Lambda function handle the onDisconnect event and update your records in DynamoDB accordingly. And when you need to send a message to the WebSocket connection, you have to first fetch it from a DynamoDB table where you've saved it before in the onConnect handler, and then you make a request to API Gateway's control plane to say, please send this message to this connection ID. So as you can see, this is all very low-level construct where you have to manage and store the connection IDs in order to send messages to those WebSocket connections. And there's no built-in support for broadcasts. So if you need to broadcast message to millions of connected users, then, well, you need to first get all the connection IDs from a database, then make like 1 million API calls to API Gateway because you can only send one message to one connection ID per request. So if you need broadcast, this is going to be super inefficient and it's not going to scale well as well. That being said, it's probably fine for simple use cases where you need to send messages to a small group of users at a time. For example, one-to-one private chat or even group chat where you have a limit on the size of the group, but it's fairly limited in terms of use cases. By comparison, WebSockets in the AppSync is a breeze to work with. It's all typed up with subscriptions which you can define in your GraphQL schema by defining a mutation operation in the top-level mutation type to capture the update that you want to push to your subscribers. Then you define the top-level subscription type and add the things that the client can subscribe to. In this case, I want the clients to be subscribed to, say, new posts that are being added to the system, so I can connect the subscription with the mutation. And when a client subscribes to this added post the subscription, then every time I make an add post mutation, the result post object would then be sent to the subscription and broadcasted to all the subscribers who has subscribed to this subscription endpoint. So you can also add arguments to the subscription operation, so it allows the subscribers to choose what events to subscribe to. Rather than having to receive every single update, I can say only send me updates for a particular event ID or if a particular author has created a new post and so on. So WebSockets in AppSync is much easier to work with compared to API Gateway, and the fact that it's also a high level construct and supports broadcast out of the box makes it really easy to build application features on top of when you don't have to deal with the underlying connections yourself. It can also scale to millions of connected clients, and so it's suitable for even the more demanding applications out there. And finally, you can actually just combine API Gateway with AppSync. It's one way to add support for, say, Lambda authorizers or usage plans or even custom domain names to AppSync, which otherwise it doesn't support right now. But one thing to bear in mind is that at the time of recording, at least, AppSync subscriptions doesn't work if you proxy the subscription request through API Gateway. And going back to the example that I mentioned earlier, where the client project where I built a new social backend for a new social network in a couple of weeks, after we went live for about a month, we had about 15,000 to 20,000 organic installed, and we were averaging around 200 to 250,000 API requests per day. And our AWS bills for those couple of months were around $60 per month, and most of that was on the AppSync caching. And considering that we were using about 5% of the cache capacity, so this whole $31.68 is going to be pretty flat, even as we scale our traffic by 10x. And it's going to save us tons of money on Lambda and DynamoDB costs. Besides what you see here, there's also another like $15 or so on the CloudWatch logs and X-Ray. And the latency for this application in general is pretty good as well. The P99 was stable around the 500 milliseconds during the day when everyone's using it. At night, it goes a bit wonky because the app is only used in Belgium. I can see that in the evenings, in the middle of the night, the P99 going up because that's mostly because of Lambda cold starts because no one's really using it. So whenever someone tries to use it in the middle of the night for some reason, then you have a cold start, and so the latency spikes up. But overall, we are still we were really happy with the performance numbers that we were seeing. And this was actually a fairly complicated system with over 200 GraphQL resolvers and over 600 CloudFormation resources. And it actually serves a mobile app as well as a different CMS system. And despite the whole complexity and the fact that it was basically just me on the back end and setting up all the AWS organizations and AppSync APIs, the DynamoDB tables and everything, while I also work part-time because I had other projects at the same time, we still end up with a system that is easily scaled to our needs, and it was robust with multi-AZ redundancy for every layer of the application. It was performant, it was very cost efficient, but most importantly, it allowed us to really move quickly, even though there's a lot of constraints on the amount of engineering resources available. So what used to take teams of engineers to achieve over months can now be done by individuals over a matter of weeks. And that's because serverless technologies like AppSync and Lambda and DynamoDB gives you so much out of the box, so you can focus on only the things that matter to your customers, and it has drastically simplifies what it takes to bring your product ideas to the market. And I hope you've seen enough to give it a try on your next project as well. And if you need any help, you can always reach out to me at theburningmonk.com and see how we can work together. And also don't forget to check out my new AppSync course at the appsyncmasterclass.com. And with that, thank you everyone, and stay safe.
Jan, thank you very much for that amazing talk all about AppSync and serverless applications. Super exciting stuff. I do wonder if you've managed to convince our audience that they should indeed be using AppSync in their apps. If you're watching along, please let us know on Twitter if you're going to be adopting that in your application moving forward. For now though, please do give us an amazing round the world round of applause. Jan will be joining me on GatherTown any moment now for his Q&A session, so please do join us there if you have any burning questions about AppSync or serverless applications, GraphQL in general. We'd love to have your input into that session. Please do post along on Twitter and let us know what you thought of that talk using the hashtag CityJS2021, as well as post along on YouTube using the comments. We missed out on the finger, Giz. That's not good enough. Thank you. He's moved it down. Jan, what a fantastic talk. Thank you very much for delivering it as part of CityJS. And we're on the home straight. And I'm sure you think that we've saved some of the best speakers until the last speakers. Am I right?
Of course, I know this. I know Max quite well. He's a really good speaker, and I guess you've got the Nader soon after as well.
And
He's one.
Jan, dream team, right? How did that talk go for you?
Yeah, I thought it was fine. Obviously, it was pre-recorded for me, so a bit easier.
I'm interested to know, do you find pre-recorded talks a little bit easier? Because if I'm right in saying you do quite a few conferences.
Yeah, I find it a bit easier. Is you have a bit more control around your delivery, and if if you mess up, you can always just do it again. There's less pressure, more control, and when you do it.
Yeah, and I like that. I like the fact that you can redo it. Personally, that's helped me out a few times because I've made some zingers on stage. Eh? Um, so AppSync, obviously, your talk is all about AppSync. Do you see that as just the latest and greatest thing in the GraphQL world to make everybody's lives super easy?
I think so anyway, but obviously I'm a little bit biased. I've been working with AWS for so many years, for a very long time until I guess until serverless and Lambda came along. I was spending a lot of my time just setting up servers, patching machine images, and configuring auto scaling and the capacity planning, all that, just so that I can ship a couple of lines of code. And I always wondered that, okay, why am I spending doing the same thing over and over, just so that I've got these 2 lines of code, and that's all my customer cares about. And then AWS announced the Lambda, and then they added more and more things they can use with Lambda, like API Gateway and AppSync and so on. And I think with GraphQL, it's just a really productive and really powerful stack.
Mm.
The downside, of course, is that you still have to run a GraphQL server. You still have to worry about that scalability and redundancy and all of that. And having someone else do it for you is just it's just amazing. And of course, AppSync give you a lot of the, I guess, nice to have features that you may have to implement yourself. Things like caching, the built-in resolver level logging, and all of that, the metrics and all of that, which again, it's just something that's really nice to have, that you don't have to worry about it. And of course, like all things are serverless, if no one uses it, then you don't pay for it. It's essentially free. So that's also pretty good as well, especially if you're, if you're building a startup. You don't, when we're starting out, there's not many users, I assume, but you don't want to be paying hundreds of dollars a month just to pay for uptime of those machines that you've got. So yeah, so I think serverless is great, and AppSync is a tool that makes you that can make you very productive. As I mentioned in this talk, I did some work with a client of mine where we build a I built a backend for a social network in just a couple of weeks on my own, whilst also just working part time. It's the sort of thing that would quite easily take a whole team of engineers months to deliver. If they have to do everything themselves.
Mm.
But with AppSync, GraphQL, and Lambda, and DynamoDB, you can just get a lot of things done very, very quickly. And the great thing is that you don't have to worry about, okay, no, what we got, we've got what we got here works, but it's not going to scale if we ever become successful, because you get that scalability out of the box, you get that redundancy out of the box. So yeah, it's my favorite stack at the moment. So
I think it's a lot of people's favorite stack. It's been a common occurrence here at the conference, and I think
okay.
that might be why AWS is sponsoring. To be honest, little name drop there for the sponsors. Thank you. One of the things that we've been asking people is to kind of put themselves in a learner's shoes and try and think why a learner should pick this up. And to add the context, Giz, who you met before me, he's currently learning to program, and we're just about to hit databases. Um,
Right.
so naturally, we were going to go down MySQL because it's kind of the standard starting place. But do you think there's an argument to be made to moving him straight on to GraphQL?
I guess with GraphQL, it's you're talking about the API layer,
Mm.
but you still have to understand databases. Obviously, if you're using something like DynamoDB, if you never used relational databases, so you don't have the baggage of assuming that's how you do things, then I think DynamoDB is actually really good for a lot of use cases.
Okay.
It's at the same time, that being said, there are lots of things that you struggle to do with DynamoDB, but certainly with with AppSync, with Lambda and DynamoDB, you can do a lot of things very quickly. And there's other services, things like Algolia, which is really intuitive to use for building search features, much more so compared to something like Elasticsearch.
Mm.
So yeah, so I think there's a lot of services out there that you can learn very, very quickly without having to spend many, many years working with them just to be competent. Which I think is the case if you're working with a lot of the other things like people talk about containers and Kubernetes, but you need like a whole degree just to be able to be competent
You do.
at managing those infrastructure.
I promise you, my degree focused a lot on Docker, not Kubernetes. And yes, I'm still not
Right.
competent in it, to be completely honest. And Kubernetes is just the next level, right? So
Yeah, yeah, absolutely. Go
we're
on.
talking here, broadly speaking, about Jamstack and that kind of thing. And I asked the last speaker the same question I'm about to ask you, and I'm interested to know what you think. Do you envisage a future where almost
Mhm.
every website is built using Jamstack, or do you think that there's space in the developer ecosystem for monoliths still?
Um, well, obviously, you can never have one solution that
No.
fits that solves everything. But I think with Jamstack is good enough for maybe like 90%, maybe more of use cases people have. I mean, we look at the things, all of these hyperscalers, but then that's like less than 0.001% of the things that are being built. Most things out there are much simpler.
Mm,
And the Jamstack gives you all the benefits of performance and security and also just being able to do things quickly and have a very productive team that you can get a lot of things done very quickly with fewer people and therefore less cost.
And I think the cost thing is very good when you're learning. You're certainly, I was worried using the Google services back in the day that I would rack up £1 million bill. And it's nice that with Jamstack, that's kind of almost built into it that you can't do that. Almost, very almost. I'm afraid to say that we are running out of time. So before I
Sure.
thank you for your amazing talk and this Q&A session, I've got a couple of rapid fire questions to send your way because we're trying to get a lay of the land in the developer ecosystem at the moment for the important questions. So my first question to you is tabs or spaces?
Spaces for me.
Spaces. I've been a spaces person, but somebody convinced me that tabs are more accessible, so I'm going to investigate that and potentially switch.
I guess for me, is I use tabs, but then have my editor convert that to spaces because that works a lot better when you're looking at things like GitHub and things like that. You don't get weird formatting issues.
I agree. I do agree. Um, if you could only use one framework or library for the rest of your life, would it be Angular, Vue, React, or something different?
Probably Vue. For me, I'm more of a backend guy. Vue is just much more accessible.
Yeah, and a lot of people have said the same thing about Vue. Actually, it's nice to hear. Um, do you prefer back end or front end?
Backend all the way.
You've already answered that one, haven't you? I mean,
Yeah.
come on. And finally, apples or bananas?
Bananas.
Bananas, yes. Bananas were losing, but they've come back with strength today. Thank you very much for that.
No
Jan, it
worries.
has been a pleasure to have you as part of this year's conference. Thank you very much for taking the time out to create your talk and for joining us for today's Q&A. Is there anywhere online that people can follow you?
Yeah, sure. You can find me on social media and all the usual places, or you can. I'm the Burning Monk pretty much everywhere. You can also find me on my blog, theburningmonk.com as well.
Strong branding there, my friend.
Thank you.
And with that, we will bid farewell to this Q&A session. If you are watching along in Gathertown, your next talk will be beginning any moment now. But don't forget, if you want to, go and head to those sponsor booths and see them before they all head off to the day. Once again, Jan, thank you very much for joining us today for this session.
No worries. Take care. Okay. Bye bye.